Swayam Prabha. Digital India. Educated India.
Good morning, welcome back to the course Computer Integrated Manufacturing. We are talking about rapid manufacturing in this week, and on the request of the candidates and the participants and the learners, I have come up with this software demonstration on Fusion 360. We have discussed SolidWorks in the previous weeks when we discussed about the CAD modeling and CNC programming. It was asked for some freeware software or the cloud based software. I'll just come up with the differences between the proprietary and the freeware softwares, or the proprietary and the cloud based softwares here. And Fusion 360 is a very common platform that is being used. It was launched a few years back, and after that it had been one of the very commonly used softwares by the students, by the learners, hobbyists, by the small startups, and so, because it has the cloud based structure in it, in which we do not need a great system, we do not need a high end computer to work with, because only the computer with the basic requirements can just get the system installed, Fusion 360 interface installed in it, and all the testing, all the analysis, all the calculations, all the drawings are made on the cloud. So, this is a software demonstration on Fusion 360. I will come back with the differences between SolidWorks and Fusion 360 first. What are differences? Okay, I will divide it into 2-3 categories. First is part modeling. Okay, category 1. In part modeling, SolidWorks is actually assembly driven software. And Fusion 360 is more known as multi-component part system. So, what does this mean? When I say assembly driven software, that means it builds a part individually before assembling them in separate files. So, when the parts are used in many assemblies as well as for documentation purposes, SolidWorks is more used. It does not mean that SolidWorks does not have the multi-component part system. It do have, but provide the amount of the flexibility, amount of the features, those are there in Fusion 360 are tremendous in comparison to what SolidWorks has. But in assembly driven software here, it means that if we change the dimensions of one component in the whole assembly would be changed. If the dimensions of the part is changed, wherever this part is used, that assembly would also reflect the change. But in multi-component part system, the components can be individually separated. The change in one component might or might not affect the overall assembly. This is the basic difference. Fusion 360 is a multi-component part system in which the components of an assembly are built and assembled in the same file. This actually makes easier for the designers to refer other components and to build them within an assembly. So, unlike the SolidWorks, Fusion 360 does not need to refer multiple files when building an assembly, although larger assemblies in Fusion 360 can cause issues. Though Fusion 360 is a freeware, its applications are limited. Always the proprietary software, the people who are charging or selling the software, they provide many functions in that, but for the amateur designers or for the startups or for the students, this is a good option to choose. So, smaller assemblies with many cross reference parts are easy to do in Fusion 360. Now comes second difference I will put regarding the simulations. When I say simulations, I will talk about the mechanical simulations. Simulations in SolidWorks, though it is a proprietary software, those are advanced. SolidWorks, similar to SolidWorks, we have ANSYS and COMSOL, which are even more advanced than this, right. But these are quick and easy to use simulations that can be carried in the Fusion 360. Fusion 360 offers many easy to use analysis packages to understand how a part will respond to the external characteristics or the external environments. These simulation packages include the static stress analysis, thermal analysis, shape optimization or so. So, this is basic and easy to use. In SolidWorks, the simulations are advanced one. They offer simulation packages with varying sets of features depending upon the purchased license, depending upon the full version or the limited version, whatever is purchased by the user. The SolidWorks Web simulation package lets you evaluate the linear and non-linear responses as well, dynamic loading, composite materials, linear and non-linear dynamics, and so on. And next important factor that differs between them is the mesh modeling. Mesh modeling is used by the designer where the points along a surface can be pushed or pulled to create an organic geometry or surfaces. So, Fusion 360 excels in this area because the mesh modeling can be quick here and it is cloud based. So, it all happens on the cloud, not very heavy evaluations are done on the computer. So, it can directly import a project into a small feature where user can instantly start mesh modeling with user friendly interface. I would better put here user friendly interface or more user friendly interface in comparison to the SolidWorks. So, designers in generally tend to prefer Fusion 360 based on its ability to easily create smooth geometry, consumer products. Some practiced or experienced learning is required here. These are the basic differences between them. First thing is this is cloud based and this works on your local or your server computer. This is completely freeware, this is proprietary. Point number 4 and point number 5. Now, let me come to the Fusion 360 platform. So, this is Fusion 360 software provided by Autodesk. So, this is a 3D modeling software and assembly software. So, we have an education license of this software here. This is for part modeling, this is a multidisciplinary software. We can use it for 3D modeling, simulation, realistic rendering, and to make small animations. So, this software is a part driven software, not an assembly driven. It is very popular among the young startups, hobbyists, students, and educational institutes as well are using this because it has easy to use interface and its free license is there. I just mentioned before. You can see the education license here. So, this is a free license here taken by a student in IIT Kanpur. So, the certain advantages I will just recall. It provides cloud support for various applications. Here we can see the basic user interface of Fusion 360. On the left of the corner we have the data panel. We have this tab where we can access all the previous files on the different portions. We can also you can see the files by clicking on them. All the files are synchronized here with a 360 cloud. It is synchronized in real time. So, you can access the 3D model at any place. For instance, you create a model here at IIT Kanpur, you can access this model without even taking along at some other place, maybe in different countries in US. You can install it anywhere because everything is saved on the cloud. So, you can access it anywhere. You can edit your design in your computer, on your laptop. The same software with your login can be accessed anywhere. So, it will just be saved into your Autodesk account. You just have to log in with your ID and access that, because this synchronizes our design in the cloud system. Here what you can see is it is a small laptop stand affordable laptop stand majorly made out of the sheet metal components. So we can view, we can rotate and pan it here. So in your default browser, you can just I am panning it. So rotating, orient, then we can also zoom in, zoom out. So many students, educators can take an advantage of this feature. So you can see, you can orient the design here. You can make a team. Different user can use the same software, same components, and they can make a team to work on it. Only the thing that you need to do here is you can just invite people. How do we do that? You can just come here. We can share the folders. We need to invite them. We are going to people, invite. We can just type the email here. So this email, whomsoever you would like to invite, you can put the email address here, and then that person can be invited to access your data. You can provide the user rights to them as well. So you can also install this in Android or iOS applications, your tablet or iPad or a smartphone. Anything can be used to use this software. This is actually the essence of using cloud-based software. Cloud-based software can be accessed from different platforms, from different when I say platform, I am talking about different gadgets. So thus Fusion 360, I believe, is best suited for the beginners. It is not only limited to us to do small things. We can make professional design assemblies which are actually manufacturable, and to some extent it can also be tested. The small stress analysis, small thermal analysis can be done on this software. Again, the cloud-based system provides you an elite advantage, a special advantage of using the extensive Autodesk computational help that is just happening on the cloud itself. So you can use that, and you can just make your drawings on your computer. So even a computer with basic specifications can use to the computer Fusion 360 for the photorealistic rendering and some basic simulation. This can also be done. So how does that happen? You can use your cloud credit to do some computation on the cloud computing, and you can use their own library. You can create your own library and their library. Like here you can see, like render, it is a foldable laptop stand. We can try to render this as well. Again render, yeah, this is the library. This is a foldable laptop stand here. This is again HDRI, photorealistic environment. What is HDRI? High dynamic range image. So you can have a photorealistic render here. So attention, so this entire computational process is happening on the cloud. So there will be no load on your machine or on your computer. See different orientations. You can use the software in a very smooth manner even when you are working with multiple models. You can design solid geometries, sheet metal parts, and also create PCB, printed circuit boards. This software has to help you create 3D PCB that is available here. Here we have environment options. We can animate. We will go for designing, rendering, animate, small simulations, basic simulations like stress and thermal. For advanced simulations, definitely we would need some high-end softwares like ANSYS and COMSOL, and also SolidWorks can also help in that. Now, in manufacturing environment, you can see these other features like to generate tool paths, like we discussed in the computer manufacturing demonstration, like milling, turning, and then CNC operations. Those can also be done here itself in this software. But since I have introduced Fusion 360 and I have also mentioned a difference between SolidWorks and Fusion 360, let me go through the UI of Fusion 360. I'll go through the various commands and features one by one. In the tab at the top, you can see we have solid, surface, sheet metal and tools. The tools tab is now open. We have tool options here. Before that, these are the solid options. We can create sketches from there. We can create sketches like in SolidWorks only. We can extrude. We can create 3D models from these sketches. This is extrusion command here. This is revolve, pattern, rectangular, and sheet metal commands are there. For more options, we have certain tools here. We have, for more options, we have modify command, and also in the drop down menu here in create, we have certain operations like box, cylinder, sphere, revolve. We can make any 3D modeling part. It says all the options other than the 5 there on the tab. So we have assembly here. In assembly options, we have in the construction also, we can offset plane, we can decide to join the axis, we can decide to join the point at axis. So these options, construction options, are very crucial to properly design the product, like point at edge and plane. And so this is inspect. In inspect, we can measure and we can put dimensions, we can measure the dimensions, we can put draft. And so in insert, we can insert mesh, XVG or 2D XF file as well. In the surface option, we can also create different kind of surfaces. We have tools here. These are tools for creating structures, and also we can modify the parts to make it a solid geometry finally. The Fusion 360 also allows to perform sheet metal operations. We have dedicated library for sheet metal as well. In the sheet metal as well, we can select any material and the thickness and its properties. There are a couple of tools in sheet metal. In sheet metal, we have certain tools. So now we have certain tools here to make or to render. So we can, in add-ons, we can write our own script if we wish, or we can directly script from the store provided by Autodesk. Here on the left edge, in the left window, we have this navigation window. We have separate commands and separate all the components, those we have already made, those are kept here. First, we need to understand the difference between the component and the bodies. What's the difference? Every component contains a single body or a multiple bodies. Whenever we change any dimension of a body of a component, it would eventually reflect in our whole assembly. So all the components are divided separately into different bodies. So bodies are actually the parts of the components. So we can attach solid components as well as C12 components into an assembly here. Since Autodesk Fusion 360 is a cloud-based system, as I have been telling before, it has several advantages over the other 3D modeling software. For example, here you can see it is a foldable laptop stand that we will make here. We can view and edit via our software on your computer, and the computation is happening on the cloud. On the left top corner, you can see we have access to all the libraries and products that Autodesk Fusion 360 has. Now, every change that we make here would be automatically uploaded on the cloud. Also, it has an online portal. You need not to install the Fusion 360 on your computer. The online portal itself would be help you to see the design that you have saved. The similar laptop stand can be seen, can be panned, can be seen on the online portal. Here, so there are so many interesting aspects that that can be discovered using Fusion 360. A few of them we'll discuss and we'll discover in the coming sessions here. So I'll just start constructing this component, and before that I like to tell you that something about the Fusion 360 environment. We can select which component we need to edit. This is the drawing already made. It has an history, the components are there. We can take the advantage of the parametric modeling and edit any of the components that we would like to change. If we make a 3D geometry of a 2D sketch, and after that you would like to change the dimensions, if we only change the section of the sketch, if we change the dimension in the sketch, the 3D geometry would itself be changed. So, let me try this. This is sketch. Right click on the sketch, edit sketch. So, this sketch, we have the dimensions here. We are allowed to access the 2D sketch environment here directly. Here already the dimensions were put as 49 mm dia and 10 mm dia. So, for this component, if we make any change here, for instance, if I make change from 49 to 39, see this dimension is changed. I am saving it. It will automatically reflect in our 3D geometry. You can see. We can use standard options for panning. See, now the dimensions are 39 now. It is 29 now. Just to see the difference, I made it a little more smaller. See, this is now 29. This link at the angle is 29 mm wide. Okay, the lower one is 39, the center one is 29, the top one is 49. Now we will come back to our original component. Now with the help of assembly option, we can provide joints here, that I will also show you when I make this drawing. We can also set the movement of the joints according to our requirement. Here we have multiple relative joints over 3 different positions. So, this is the model that we will make. You can animate your model with the help of the joints that you have made here. We just need to right click and click on animate model. See, the animation is being shown here. The angles are between 0 to 45 degree. We can press escape button to escape this animation. Pressing escape button will stop the motion. Like in SolidWorks, I would again suggest to keep your left hand, one of the fingers of your left hand close to the escape button bed, because that is most of the time requires to keep escaping from the points. Now, in the assembly chain, in the bottom, you can see the entire history of the operations, entire history of the steps that we went through while making this. We can just click at any step and make changes. We can move to that step directly, like for instance, if I click here and this specific step, right click here, then I come to rule history marker. It is showing history marker at this stage. This was the position, this was the status of the drawing that I was making. So, we can make changes here as well. These changes, whatever I make here, would again happen in the final assembly. If we wish to see the entire process, we can just go to the first step in the history marker and we can play the history button. Here is play. Either we can play, it would play the whole history, or we can just keep clicking on the next button. You can see that the system is guiding us step by step through the whole process, how the drawing was made. So, in this way, how can you benefit? For suppose if one of the friends in your group is a little expert or little comfortable while using this software, that person can make the drawings, and the beginners can just watch the history, that how the drawings were made. At any point they can come and see the dimensions, they can see what were the steps those were followed while making this drawing. home. So this is the original position now. So this is the component that we will make, and I will just go through the various steps in this. I will try to make links first, the links, then I will try to make the hinges or the hinge support for our laptop top, then I will make this sheet. This sheet, actually this is the top face of the laptop, that I will make in the later parts. So these components I will just make, and also the screws are also required, the screws, and I will also try to use a screw as a tool to cut the hole in my link. So let us go through the steps for making this. So I have come to sketch here, sketch environment. So in this is the center here. How do we start it? First I will make the part that is link. I will come to create tab in this. In create, I will select line, select a line, click on center, and we can put dimensions 210, 210. Okay. Now I will create a new sketch. I will like to create here a slot, center to center, this center to this center, it will create a slot here. Now I need to provide the width of my slot. I will making it 49. 49 is the dia, that becomes the width of the slot. Now I create a circle here. This is the hole for my screws or the pins. The dia is 10 mm. So this is another circle, again 10 mm dia. Now we can delete this constraint by clicking and just pressing the delete button. So we select the profile here and finish the sketch while clicking finish. Now we are in the 3D environment here. Now in solid environment, I select the profile and extrude that. Extrude it as a new component. New component, new body, two options are always there. As a new component, we can make changes independently. For the new body, it will become as if the part of the any changes in the previous body would reflect in the further body itself. So I can just extrude it as a new component. Okay, 5 mm thickness. Now this is the link that is ready. Now our objective was to create links like this, like in this design. You can see there are 3 links on the left and 3 on the right, total 6 links of same dimensions. So let us try to continue this link. We need to create copies of this link. You can show or hide the constraints, geometries or sketches here. So this is sketch. Okay. Now this component is to be copied. What do? I double clicked on my geometry, select the part, that is right click on it, then I copy it from here and we can paste it here. Paste and paste new. Again, paste and paste new, 2 options are there. When I say paste, it will just paste as a copy of this, and any change in the primary component would reflect in the any further components. Those are made from that. Paste new would be an independent component in which the changes can be made independently. So paste new is the one that I would like to do here. So it is asking a new link is created at that place itself. So we can move it in different directions. We can arrange it, or actually this has to be a center has to be aligned. So I will select a pivot point here, a pivot point, pivot this from point to point, or center to center is better. I will move from center to center. This point is aligned as a center. then I can move this. Now these 2 points are aligned, and also we can see this component is -5. -5, now the components are completely attached to each other because the thickness was 5. So, -5 has taken it at the 5 mm distance. Now, they are completely rubbing with each other. So, we can rotate it along the center line on the both links because it is pivoted here. So, let me put some value rotated up to some angle, let me say -40, -40 is okay. Okay. Now, these 2 links are created. So, a third link can also be created in the similar fashion. While right clicking on the component, select copy, and then I go to the open space here, workplace here, and click there and paste it here. It is pasted this component on the component, it is a complete overall overlapping. So, I select the pivot point here, the component is now rotating. Okay, the component has to be offset by 5 mm. I can offset it by 5 mm, -5 mm here to make it look like this. Now, these links are ready. Another 3 links. Now, I can select the components, again right click and copy. I can Control C and Control V, it can also be used just like in MS Word. Control C is for copy. Now, Control V is paste. It is pasted here. So, I can provide the distance between them. The distance would be equivalent to my sheet, my top sheet. It is -460. -460 value that is put here. This distance, let me check it here. Yes, it is 460 mm. Now, similarly, we can complete the second link, copy C and copy V. Again, the distance between them -440. Again, Control C and Control V. It was 440, 10 mm on this side. So, it will be -420. So, I have similar links here. Next thing that I will design here is my sheet metal component. The top face has to be designed. Before that, I have to design a hinge here. This hinge it will be fixed below the sheet metal component. This hinge support, I would say, for sheet metal, this is to be created. I will just make a simple rectangular hinge here. So, first we need to make a sketch here. For that, I will pick rectangle, a 2-point rectangle or a center rectangle, because we have the center here. We select the center here and make a rectangle. The dimension for rectangle is the dimensions are 40 cross 20. Oh, I got it the other way. It is 20 cross 40. I will make this dimension as 40, and this side is 20. 40 by 20 rectangle is there. We select the profile and I will extrude it to make my hinge. So, on your keyboard, we can press E for extrude command. So, in extrude, I have put 80 mm. 80 mm distance is the extrude length. So, this is created as a new component. Now, we have this hinge support here. So, again we can Control C and Control V, a new component is created. For alignment, this different options: translate, rotate. We can select point to point. We can just put this point this point here. This is first point and this is the second point. These center points are now aligned. Now we have created two hinge supports. Now, as the geometries are not independent, the parent geometry, any change in the parent geometry would bring the change in the other geometries created from it. Now we will make this top sheet. This is a sheet metal. This is sheet metal component. So, for this we can select sheet metal option here. Sheet metal. Okay. Now, this is the sheet metal environment. First, we need to make a sketch. Select a sketch here. Then define my plane. Now, I have selected the plane, that is the top surface of my hinge support. It is selected this plane. We can make our geometry here. The size of the geometry is to be put here, and this size is in our case it is 420 cross 256 mm. 420 is my length and 250 is the width of the top base of the top plate. Now 420 has got overlapped it. I will make it 410. Now yes, it is 410 by 256. Actually, before making the drawing, you have the dimensions ready with you. I am just trying to make a model just to portray the different features or to show the different features. So, I am selecting the dimensions accordingly. So, we can make a flange here. So, we need to select geometry to make the flange. So, in this you can see the different materials options are there: steel, aluminium, SS, and so we can select it as a new geometry or new body, and always it is important to select it as a new component. If we make a new body, we won't be able to make an independent change in that. We have to select it as a new component here only. I select it OK. I have come to the base design here. Now I need to create flange here. You can make a bend or a flange. Again I will make a flange, select the flange option. From the parent sheet metal I need to select the geometry where I like to make the flange in this direction. Okay, now it is making the flange. All I need to do is just to pull it in the distance, any distance that I need. I can put the distance here. Let me take it 25 mm here. Okay, the basic dimensions here are 25 mm. If I need to change the dimension into inches, only I think need to do is I will need to put 25 IN. Now it has taken it as 25 inches, but I need to put that in mm. So this is 25 mm. Select OK, and this is done. So come back to solid geometry. Now I will start to make joints. And before that I need to insert pivots. Now in Fusion 360 we can import different components here. We can import many number of components with using several libraries provided by, like this is Mac Master Car, in which we can select the different kinds of components. It is just showing the different kind of fastening and joining. So you can see the different options are available: electrical and lighting components, fabricating, fastening, joining, filtering, flow and level control, furniture, hand tools, and so on, like material handling, measuring and inspection. So they are fastening and joining. Different kinds of joining components are there. We have screws and bolts, threaded rods and studs, eye bolts, U bolts, nuts, washers, shims, spacers, pins, and so on. Nailers are also there, rivets, etc. are there, staples are also there. So we will select the screws and bolts here. In this screws I will select metric threads screws with countersink geometry screw. I need to select with metric thread, and the dimensions were 10 mm. flathead screw. I will just select once, and I need to select M10. Okay, this is selected. It is now trying to search for the screw and provide us with the one. Yes. Now we can select the length of the screw here. I can pick maybe from 20, 18, 16, 20 would also work. Okay, let me take 16 fully threaded screw. Product detail, we can see it here. So this is the product detail. We can download the file in these formats, PDF, SAT, SolidWorks. It is generally suggestible to import that in STEP format. So I will save this screw here. Now this screw has come here. Now here is the component that we have. Now we need to place it at the right spot, for which I will just move it point to point. Now this point and this destination point. It has put the screw at the right place. Now one thing is missing here, the countersink hole in our link. So you can see we need the specific geometry here. Here you can see there is no countersunk hole there. This countersunk profile has to be created here. What I can do here is I can create this screw as a tool. I will select the combine option and select machine, select a target bore guide and a tool body and cut. Keep the tools and OK. I will repeat this. What I am trying to do here is I am going to use this screw as a tool and my link as the material that is to be cut. So how do I do this again? So I will come to combine, capture position. I will select the target body is my machine, tool body is my screw, and cut the portion, and also we need to keep the tools. OK. Now you can see here we have a countersunk geometry created in my 3D link here. All I need to do is repeat the process for all the joints. We have 1, 2, 3, 4, 5 other joints left. So copy and paste and take it to this geometry point to point. I am quickly doing it. Copy and paste and point to point from this point to this point. So I have created in this side the screw. Similar screws can be created on the other side. Now I will start to put joints here in the assembly. Let us make some rigid joints. I need to make sheet metal and the hinge support as a rigid body. Now this has become a rigid body. Whenever I move this has become a kind of a permanent joint here. Wherever I move this body, both bodies are kind of now one body. They were created separately, but they have become a rigid joint here. Now I need to select my pivot point here for rotation. Select M for move, select my pivot point here. This is my pivot point, and select pivot point. We can rotate it here. Yes. Now let me put some value, 30 degrees. Okay, minus 30 degrees. Now we can provide different joints between the links. We have separate links here. This is the first link. This is my second link. This face. it is better to isolate the components. Since so many components are, I can isolate these two components from the other component. You can select these two components, this plus other component. So, I have selected both components while pressing control, right clicked on them and isolated them. Now, we can freely work on these two joints, these two components in which there is one joint. I can select come joint, capture position, select first component and second component. See, the screw that was there before, that was bringing its profile and the screw threads were being shown. So, I have isolated these two components to work on only them, and I can create the joint here. The joint type here will be revolute. It is now showing a complete 360-degree revolution. Now, if you joint anything, suppose these two components are completely in contact with each other. If I try to start rubbing them, there will be a lot of friction in them. So, there need to be some clearance between them. It should have some, it could be rubbing like this. It should have some clearance so that the joints are free. So, that clearance I will provide here. So, I provided this clearance here. Now, I am offsetting it to provide the clearance. So, it is now some clearance is there, you can see here. So, let me put angle here 40 degrees. We can also constrain the motion. How to do that? We need to put the minimum and the maximum angles. Minimum would be 0, maximum would be 40 degrees or 45 degrees. So, I can isolate them here to see the whole assembly. To animate the joint, we can also see the animation here. So, it is still showing 360 degrees. For that, to constrain it from 0 to some angle, I need to do this. So, we have already created this model. We can see the properties of the geometries and the joints here. So, how did that happen? We can see here, this is the joint, right click, constraint modeling, right click, edit joint limits. You can see edit joint limits, you can see the minimum and the maximum. Minimum is 60 degrees and maximum is 45 degrees. So, similar things we can use there. Again here edit joint limits 0 to 45 degrees in negative direction. The directions, one is direction minus 45, another one is directions plus 45 degrees. We can also animate the model here. See, this animation is the one that we would wish to create in our model. So, how do we do that? I will select these two links or these three links together. We can select these three links together and the hinge wherever we need to join. Now, these four components are taken and isolated. We can select the joint origin, capture position, and these two joints are to be rotated, first face, second face, then I select. Now, this is 360 degree rotation once. Now, I need to constrain the rotation to 45 degrees. We can provide a constraint later. For this also I need to join this, select joint, capture position, first phase, second phase, and select first profile, second profile and revolution. This is second animation. Okay. Similarly, this and this, again capture first profile, second profile, again revolution is possible here. I will offset it by 10 mm to provide clearance. So, I need to select the joints again here and provide the complete revolution. Now, the whole revolution is almost ready. again providing the offset here. I provide epsilon to maybe minus 4.8. Okay. Now the whole revolution is almost ready. Now I need to provide constraints to this revolution so that the revolution is limited to some angle, maybe 45 degrees or 30 degrees for the hinge. How do I do this? I right click and edit joint limits. Minimum and the maximum values could be put here. The minimum is 0 degree and the maximum for the hinge support is minus 30 degrees. And for this first link, edit joint limits, minimum is 0, maximum is, I will do minus 45 degrees. This would go in minus or plus 45 degrees, plus 45 degrees. Minimum is 0 plus, and this is minimum 0 and maximum is minus 45 degrees. This is the product that is ready, and let me try to animate this. I have just clicked right click on the body on the whole product and clicked animate. So, this is the component that is ready. Here I like to stop and finish this lecture. We will meet in the next lecture where I will discuss about the rapid prototyping concerns, and also I like to discuss something about the rendering, about the appearance, about the showing the components, about downloading, about the saving the product that we have made in JPG formats. We can choose different environment, different backgrounds for them. We can choose the environment like in a machine shop or in a room for furniture. This kind of laptop stand we can consider room. How does it look like in our room? So, this we will discuss in the next lecture. Thank you so much.